All right. So what we're looking at today are I am recording now, FYI. But again, you don't need to do anything different. We're recording in class live today, so sorry for the background noise. All right. Ready? So we're going to look at half-angle formulas today. We looked at double-angle formulas the last time, so this is kind of the reverse of that. So here's the three half-angle formulas. Alrighty? So let's say that I wanted to find the cosine of like 22.5. I don't know that one. But 22.5 is half of 45, and that is an angle that we know. So we can kind of work that way. Again, all of these formulas are just kind of expanding the possibility of finding exact values for angles that maybe aren't directly on our unit circle, but they're going to get us where we need to go. So here are your three formulas. I'm not going to read them out loud because you can see them there on your paper. But what is important to notice, we are used to getting that plus or minus in front of a square root, and that meaning that there's two possible solutions. That is not the case here, okay? You are either going to choose positive or negative based on the quadrant that the angle is in and what we know about the signs of the 6 trig functions in the different quadrants, okay? So it's whichever angle the half angle lies in. So for example, on number 4 here, 112.5 degrees, which quadrant would that be in? 2, because it's just a little ways past 90, and that's the quadrant that we're going to use to choose the sign. So, so there's a typo here. Can you tell what it is? There's no trig function there for number 4. The exact value of 112.5 degrees is 112.5 degrees. So we got to pick a function to work with. So let's pick cosine. All right, I need my little sheet. Here we go. All righty. So add this in on your notes because this is pretty much meaningless without it. Find the value of the cosine of 112.5 degrees. Okay. So 112.5 degrees is in quadrant 2. In quadrant 2, is the cosine positive or negative? The cosine of theta is less than 0 in quadrant 2. So it is negative. So that means we're going to choose the negative square root when we use our formula. Okay? Now, we have to decide what alpha is. We need a situation where alpha over 2 is 112.5 degrees. So what angle would that be for alpha? 225. Now, what's a good clue that we might want to try using a half-angle formula here? Well, not just the decimal point. The fact that it's 0.5. It's half. If it was like 0.7, that's not gonna. We don't have a 7/10 formula or anything like that. So yeah, the fact that it's a 0.5 is a good clue. That's not the only time that you could use it, but that is a possibility. I could do 150 and use that on 300. But why? Because we already know 150. So, just kind of depends. So that's what we're going to use for alpha when we work this out. So the formula for cosine, the cosine of alpha over 2 is equal to, and this is just off of your sheet, plus or minus the square root of 1 plus the cosine of alpha over 2. Now, we already said we want the negative one based on quadrant 2's rules for cosine. So, the cosine of 112.5 degrees is going to be equal to negative square root of 1 plus the cosine of alpha, which is 225 degrees, over 2. And we can evaluate that from there. So 225, what would its reference angle be? 45, that's right. So a 45-degree angle. The cosine of 45 is square root of 2 over 2. But which quadrant has 225? 3. And is the cosine positive or negative in quadrant 3? Negative. So we want negative square root of 2 over 2. So we get negative 1 minus the square root of 2 over 2 over 2. And here's our old nemesis, the complex fraction. So when we go to work underneath here, I'm going to write it this way. 1 is 2 over 2, correct? So we can get a common denominator in here pretty quickly. We end up with 2 minus the square root of 2 over 2 times 1/2. Where's that times 1/2 come from? That's the keep, change, flip piece. If we're going to divide by 2, that means we're going to multiply by 1/2. Do you see that or no? Like we have the square root of 2 minus 2 over 2 all over 2, which means we're going to multiply by 1 over 2. Because we have to, okay, let me rewrite it so that we can see this. I'm skipping too many steps for you guys. So we get 2 minus the square root of 2 over 2 all over 2. So how do we divide fractions? We keep, change, flip, which means we're going to end up multiplying by 1/2.
Oh.
Because right now this is 2 over 1. Oh.
What? Oh my gosh.
That's okay. All right. So we end up with the square root of 2 minus the square root of 2 all over 4, which we would need to rationalize, except what? Yeah, the square root of 4 is 2. Remember, we can treat this like 2 separate square roots. Oh, I dropped my negative. So this comes out to negative square root of 2 minus the square root of 2 over 2. That's the stuff nightmares are made of, right? Like you've got a square root under your square root. But that is the exact value. Could you get a decimal and approximate that? Absolutely. But so could your calculator. You could just put in cosine of 112.5. But we want the exact value, not the decimal approximation. That is your answer. It's ugly, but that's your answer. No, we cannot. Like the square root of a square root, those don't undo each other. The square root of a squared, those are inverses, but square root and square root don't undo each other. And if you think about what that means, like if I had the square root of x, the square root of the square root of x, what would this look like if we changed it into exponents? This would be x to the 1/2 to the 1/2. What do we do with exponents when we do a power of a power? We multiply them, that's right. So this would really be x to the 1/4. It doesn't undo it. It ends up doing like a higher degree radical. Good question. Other questions? Okay.